Chapter 5 Review. Do you remember that I mentioned something about Chapter 5 is going to be the most difficult of the chapter that we discuss in this course? So I'm glad you guys are finally arrived at the last chapter of Chapter 5 so that we can take the chapter test and move on. So please make sure you practice. Don't forget to practice your 6 trig ratios. Even though we are finished with Chapter 4, Chapter 5, we will still need that information to carry us through the remaining of this course. So the trig ratio is going to stay with us. Make sure you practice. And you might have noticed that the trig ratio, 6 trig ratio, will greatly benefit your learning in Chapter 5. So back to the topic. Review. Simplify, show all your work. Make sure you show your work. Otherwise, I cannot read your mind. You cannot simply guess the answers and then just come out of nowhere and give me the answer. I need you to show your work because this is the logical process that you will require to practice in Chapter 5, the logical reasonings. So number 1, secant x times cotangent x times sine x. So remember I said if there's nothing else you can help you, stick with sine and cosine. So I would like to use the reciprocal identity for the secant, which is 1 over cosine. Cotangent, I use the quotient identity, which I can rewrite into cosine over sine. And sine is already itself sine. So what do we have here? 1 times cosine times sine, that's for the top. And at the bottom, I have cosine times sine. They're exactly the same thing, so I can reduce them, top and bottom. Sine over sine, cosine over cosine. So that's 1. Number 2, 1 minus cosine square x times cosecant square x. Whenever it comes to the square, remember I said, think about Pythagorean identities. And only square you can quote the Pythagorean identity. So please remember, Pythagorean theorem only applies to square. So 1 minus cosine square x, I can rewrite that into sine square x. Cosecant, again, I like to stick with sine cosine if possible. So I'm going to use the reciprocal identity, 1 over sine. So sine square x divided by sine. So that's degree of 2 divided by degree of 1. So I can reduce 1 degree. Reduce is down to sine x. Number 3, cotangent square x minus cosecant square x. So cosecant square x, so as you see, square, do you see that the square? So when it comes to square, think about Pythagorean identity. Think about Pythagorean when you see the trig ratio is being raised to second power. So cosecant square x can be written as cotangent x minus plus 1. Cotangent square x plus 1. So don't forget, you are subtracting the second parenthesis. So cotangent square x minus cotangent square x minus 1. So the final answer is going to be -1. Number 4, 1 plus cosine x minus cosine square x over sine x minus cotangent x. So here, again, I see the 1 minus cosine square x. So I deal with these two terms first. 1 minus cosine square x equals sine square x plus cosine x divided by sine x. So I'm going to divide individual terms. Sine square x divided by sine x. So that's sine x. Cosine x divided by sine x. That's cotangent x. That's exactly cotangent x. So here you do not see me asking you to transform the cotangent x into cosine over sine. So sometimes you want to stick with sine and cosine. Sometimes it might be easier for you to directly recognize and then quote the identities that we discussed before. So quotient identity, cosine over sine is cotangent. So cotangent and cotangent, they get cancelled from each other. So as I use the word cancel, it means cotangent x minus cotangent x. When you are dividing, I use the word reduce. So please make sure you know the relationship here. Number 5, cosecant negative x. So here I'm going to quote the even and odd identity. And I know cosecant is an odd function. So I should get negative cosecant x. And then the second term, I have cosine x over cotangent negative x. Cotangent, again, is an odd function. So it becomes negative cotangent x. Then I use the reciprocal identity to rewrite cosecant into 1 over sine x. Cotangent, I use the quotient identity cosine over sine. When you divide by a fraction, again, divide, we do not really divide. We use the reciprocal. We take the reciprocals. So everything get reduced down to 1. Isn't that beautiful? And I think that the trig identity is kind of playing with the symbol games. You're not really actually dealing with numbers. You're just dealing with symbols. Number 6. Sine 90 degree minus x over cosine 90 degree minus x. So when I see the 90 degree, sometimes you'll see this as 90 degrees. Sometimes you will see it as pi over 2. Pi over 2 is exactly the same as 90 degree. 90 degree is exactly the same as pi over 2. So make sure you recognize these two representations. And then whenever it comes to 90 degree minus x, this is quoting the co-functions. So the co-function for sine is cosine. So the top part becomes cosine. Co-function for the sine, cosine is sine. So the bottom becomes sine. So what's cosine over sine? What's cosine over sine? We practiced it quite a bit, like example number 4. That's the quotient identity for cotangent. Number 7, sine x times cosecant x minus sine square x. So have you recognized that sine and cosine, sine and cosecant are the reciprocal of each other? So that should be 1. 1 minus sine square x, again, square, think about Pythagorean identity. So everything get reduced down to cosine square x for number 7. Number 8, secant x minus sine times tangent x. So the first one, secant x, I'll rewrite into using the reciprocal identity, which is 1 over cosine. And then the second one, sine times tangent, I'm reusing the quotient identity, which is sine over cosine. So since I have the same denominators, cosine x at the bottom, so I can add and subtract the top. So the top I have 1 minus sine square x, which is cosine square x. So what's cosine square x divided by cosine x? Cosine square x over cosine is cosine x. Number 9, cosine cube x plus cosine x times sine square x. So there are two terms for this particular function. What are the common factors? So think about the common factors. Do you recognize that the cosine x are the same terms for both of the terms? So I can factor it out. This is a function. You are not solving an equation. So make sure you factor it. You are not supposed to divide everything by cosine x. If you're going to divide, you have to have something, an equation that's on the right hand side so you can divide. You are just factoring it out, meaning that your second step would have to be the exact same thing as your previous step. So as you factor out the cosine x, I get cosine square x left, I get sine square x left for the second term. So cosine square x plus sine square x, isn't that the basic, the very first Pythagorean identity? Cosine square x plus sine square x equals 1. So cosine x times 1 is cosine x. Number 10, you have cosine square pi over 2 minus x over 1 minus sine square x. So do you remember that I said in number 6, sometimes you'll see pi over 2, sometimes you'll see 90 degree. They are exactly the same thing. So this is going to quote the co-functions. So cosine square x, pi, cosine square pi over 2 minus x, that's calling for the co-function for cosine, which is sine. So that turns into sine square x divided by 1 minus sine square x at the bottom. And 1 minus sine square x is exactly the same as cosine square x. So this is sine square x over cosine square x. And we know that sine over cosine is the definition, is the quotient identity for tangent. So that's basically representing tangent square x. Number 11, sine x times cosine x over 1 minus sine square x. So there's nothing much I can do about the top numerator. They are already in sine and cosine. Sine x times cosine x. There's nothing more I can reduce. How about the bottom? 1 minus cosine square x. So that is using the Pythagorean theorem to rewrite into sine square x. So sine and sine get reduced. We are left with cosine over sine, which is the quotient identity for cotangent x. Number 12, 1 minus sine square x over tangent square x. So this one I'm not going to do something about the 1. I'm just going to rewrite the sine square x over tangent square x using the quotient identity. So I reduce that onto 1 minus cosine square x. And 1 minus cosine square x is sine square x. Number 13, verify the identity. So this is the trig identity proof. Trig proof. So if you decide to pick on one side, stick with that side. Do not touch the other side. You have to stick with the side that looks more complicated. So look for the side that's more complicated from the beginning. So the left-hand side looks more complicated as you have two terms, cosecant times tangent. Cosecant times tangent, as I rewrite into 1 over sine for representing the cosecant x. Tangent, I'm going to rewrite into sine over cosine. So 1 times sine divided by sine times cosine. So sine and sine get reduced. You are left with 1 over cosine. And 1 over cosine is exactly the same as secant itself. That's the reciprocal identity. Number 14. 1 minus sine square x over 1 plus cotangent square x. So again, I think left-hand side is more complicated than the right-hand side of sine square x times cosine square x. So I'm going to stick with the left-hand side. On the top, I have 1 minus sine square x, that's cosine square x, that's the Pythagorean identity. On the bottom, what's 1 plus cotangent square x? 1 plus cotangent x, I just go ahead and rewrite into 1 plus cosine square x over sine square x, which is the quotient identity. From there, I can reduce and combine, make into the same denominators. So I have sine square x times cosine square x. Another way for you to prove this one is if you recognize that 1 minus sine square x, so 1 minus sine square x is cosine square x. 1 plus cotangent square x is actually cosecant square x, which is at the denominator. And then cosecant square x is exactly the same as sine square x because the reciprocal identity. So this one might be easier than what I'm doing here. So either way, you should show your logical thinking, show all your work. Okay? Number 15, I have sine x times cosecant x minus sine square x. So have you recognized that sine x and cosecant x are reciprocal of each other? So you should get 1 as you multiply the functions with its reciprocals. So 1 minus sine square x equals cosine square x, which is the Pythagorean theorem here. So as you can see, we have been using quite a bit of reciprocal identities, Pythagorean identities, even odd identities, co-function identities. So make sure you review, practice your trig identities. Number 16, cotangent square x plus cosine square x plus sine square x equals cosecant square x. Have you recognized that cosine square x plus sine square x equals 1? And then cotangent square x plus 1, that's the third Pythagorean identity. Cotangent square x plus 1 equals cosecant square x. Number 17, secant square x times cotangent x minus cotangent x. So for this one, I recognize that the cotangent x are the same for both terms. So I factor it out. I have cotangent x times secant square x minus 1. Secant square x minus 1 is tangent square x. So what's cotangent and what's cotangent times tangent? They are reciprocal. So that basically means that you have 1 times tangent x, which turns out to be tangent x. 1 times tangent x is just tangent x. Number 18 is exactly the same as number 15. Number 19, you have tangent x over 1 plus secant x plus 1 plus secant x over tangent x. So this time you would have to find the least common denominators. Because they are different for the denominators, So the easiest way is by multiplying each other. So meaning that the first term I have to multiply tangent x over tangent x. The second term I have to multiply 1 plus secant x over 1 plus secant x. Once you have the same denominators, then you can add the numerator. Reduce, then you get 2 cosecant x. Number 20, 1 minus sine square x over 1 minus cosine x. So again, you do not have the same denominator, so your first job is to make sure you make them into the same denominators. So this 1, the very first number 1, I have to make it into 1 minus cosine x over 1 minus cosine x. Once I have the same denominators, we'll operate on the top for the numerators, and then as you can see, 1 minus sine square x turns into cosine square x. Cosine square x minus cosine x. I have the same factor of cosine x. As I factor it out, then I can reduce the bottom. So that turns out to be negative cosine x as my final result. Number 21, tangent square x over 1 plus tangent square x. So at the denominator, I see that 1 plus tangent square x becomes secant square x. Secant at the denominator, so that's basically looking for the reciprocal, which is cosine. So what's tangent times cosine? Tangent times cosine turns out to be sine square x. Tangent times cosine turns out to be sine square x. Number 22 through 33, we're looking at the intervals from 0 to 360s. 0 to 360 degrees. So make sure you check your domain. It's going to be from 0 to 360 degrees. So think about the linear equation that we discussed. Make sure you get down to the trig equations, trig functions first. Get down to the trig functions first, and then think about the reference angles for the values that it will give you the ratios that you're looking for. So get down to the trig ratio first, find the reference angles, and find whether it's a positive or a negative value for each of the trigonometry functions. Which quadrant will give you positive values? Which one will give you negative? So make sure you check that. 28 through 33. So we just discussed this as the last day of our discussion of chapter 5. These are multiple angles. So if you have a multiple of 2, make sure you have to add 1 time of 360. You have to go around the circle once. If you have the multiples of 3, your b is 3, then you have to go across. You have to go around the circle twice. If you have 4, b is 4, then you have to go around the circle 3 times. If you have b equals to 1/3, b equals to 1/3, that means you're horizontally being expanded, being stretched to 3 times the original period length. So then you basically be out of the 0 to 2 pi way faster than itself. So basically you are looking for just one angles. So do your practice and check on your answers. Ask me any questions you may have before the chapter test date. Make sure you practice this, and I need you to turn in your review paper on the chapter test date.